Okay, so this is the free response question that we are going to take a look at. So take a minute to pause the video, read the question, maybe even try it on your own, but I'm going to go through it with you. Remember, this is FRQ 2, which means that you do have a calculator. So the first thing I'm going to do when I'm reading a question like this is I'm looking for essentially the points that they are giving me in the word problem. And it tells me that after 2 weeks, Mr. Castwater's maximum bench press was 230 pounds. So that means the point 230, falls on my line, or my regression rather. After week 9, so x equals 9, he has a maximum of 270 pounds. So that's my second point. They tell me that the function is going to be modeled by m of t equals a plus b ln of t. And part A1 is always going to be to write two equations. So 230 equals a plus b ln of 2. And then 270 equals a plus b ln of 9. So there is my two equations and my first point. A2 is always going to be to find those decimal approximations. So remember, almost all the time we're going to be running a regression in L1 and L2. So I'm going to put in the points 2 and 9 into L1 for my input, 230, 270 for my output, my L2. And then I am going to do number 9, which is ln reg. So on my calculator, stat edit. If you have anything in here, you're going to go up and hit clear, never delete, always clear and hit enter. So 2, 9, 230, 270. Stat calc, like I said, I'm choosing choice 9. L1 and L2 are by default. You are always going to store your regression equation because it's going to be extremely helpful to us in future parts of the question. So alpha trace, enter. Here's all of my information. So I'm going to copy this down. Remember that we're going to 4 decimal places and we are truncating. So that means that A is going to be equal to 211.5661 and B is going to be equal to 26.5943. Now, those are my rounded values. However, you always want to use unrounded values in every other part of the question, which is why I stored it into y1, because if I go to y1, there is my unrounded function. So I'm going to have the most accurate when I am looking for different things in my calculator, a maximum, a minimum, a zero, domain restriction, range restriction, things like that. So now I'm going to move on, 2 points I've gotten so far. I'm going to move on to the next part, which is always going to be an average rate of change. So for this question, they're asking me to find the average rate of change between those two values they already gave me. Remember that average rate of change is always going to be y2 minus y1 over x2 minus x1. My pen is a little bit off right now. So I'm using the values that they gave me, not the values in the regression equation. So I am using 2 and 9. They gave me 270 and 230. When I put this into my calculator, I'm going to do it right in the home screen. Alpha y equals, to set up my fraction, 270 minus 230 over 9 minus 2. It's going to give me a fraction of 40 over 7. I'm going to write that down because I want to use that as my exact value in future parts of the question. But remember that in order to get the credit for this part, it needs to be as a decimal. So in my calculator, I'm going to hit math 2, enter, and it's going to put it as a decimal for me, 4 decimal places. So this is equal to 5.7142. There's my third point. Those 3 points should be almost guaranteed on every single FRQ2. From here, it's going to be some kind of analysis question. So if they are asking about concavity or secant line or confidence in certain values, these are all the different things they're going to be asking about potentially. In this particular question, it is the easiest one in my opinion. It is asking you to interpret the meaning of your answers, the meaning of the average rate of change. Remember that it must have the phrase on average. So I like to start with that so I don't forget it. So I'm going to start with on average from t equals 2 to t equals 9 weeks. Mr. Passworders maximum bench press, because you always want to reference in context. Since my average rate of change is positive, that means it is increasing. If my average rate of change is negative, I would say decreased. But it increased by 5.7142. That's my answer from the previous part. Pounds per week. Remember that you must reference each week what is happening, or each day, or each year, or whatever your X value is. So there's my next point. Then I move on to part 3. This time, it's a little bit challenging for this question. It's not asking about a secant line. It's not asking about my different rates of change or things like that. It says, let E of T be the estimate of Mr. Passwater's maximum bench press in pounds after T weeks using the average rate of change found in 1. Okay, so that means that E of T involves my average rate of change, which implies it is linear. It is essentially talking about my secant line. It then says it is known that E of 12 is equal to 2, oops, hold on a second, is equal to 287.14. It wants me to compute the residual of this estimate compared to the value of the value given by the model for M of 12. And then it says, for t is greater than 9, the residuals of the estimates will always be negative. Explain why this is true. So there's a couple of different things happening here. Let's first start with residual. So a residual is equal to actual minus predicted. They told me the predicted was E of 12, which is 287.14. So hopefully you're with me so far. The actual is going to be M of 12. Now, it's not really the actual because it's not a data value, but it is the model. Okay, so in this case, they don't mean actual, they mean model or the predicted. Okay, so it's a little bit hard because they're both predicted. But I am now going to go back to my calculator. I already have this function, my model, M of t, stored into Y1. So in the home screen, I'm going to do alpha trace 1 of 12. So M of 12 is 277.65 and so on. And I always want to use unrounded whenever possible. So right here, I already have this stored. So I'm going to do this minus 287.14. So here's my residual. So my residual is negative 9.4892. That was the first part of this question. But then it says, for t is greater than 9, the residuals of the estimates will always be negative. Explain why this is true. So here is basically that question where it wants you to compare your secant line to your model, but it's just asking it a little bit differently. Instead of asking about the rates of change of those, it's talking about the residuals. So remember that residuals are actual minus predicted. So if it's actual minus predicted, and I am getting a negative value, so I have actual minus predicted. If I'm getting a negative residual, that means that my predicted was above the actual. And go back to here. My predicted was larger than my actual, which means that my secant line is above the model in this case. So I want to talk about that concavity and that behavior of the graph. So if you need to, you should be able to graph your function. It's already in y equals. I always like to start at Zoom 6, but it's totally up to you. You can either play around with the window if you want, or you can just try a Zoom 0, or you could just try a Zoom out, totally up to you. But you just want the shapes. You may not even need to see the graph. You may know based on your features of log functions, your transformations, your parent function, and so on. But this is a log function that's concave down. So since my log function is concave down, and since my secant line would be connecting, let's say, these two values, whatever it is, it forms a straight line. Over here, if I'm looking at this portion of the graph, which is t is greater than 9, my secant line is always going to be above my log function, and therefore my residuals are always going to be negative. So we just have to write that in a sentence. So for t is greater than 9, the residuals will always be negative because E of t represents the secant line, which is above the model m of t on that interval, since m of t is a concave down logarithmic function. This is a difficult one in general, but this one that now combines your secant line with your residuals makes it even more challenging. But remember, it's only 1 point. You can guarantee yourself 3 points on this question. Hopefully, one of the analysis is easier, like the one that we just did with the average rate of change interpretation. That should be easier. So I already have 4 points, and 4 to 6 points on an FRQ is very good. So now I just need to go and do my last part, part C. Mr. Passwater decides that he should use Model M to make predictions about his maximum bench press beyond 12 weeks, as long as the difference between the predicted maximum bench press as long as the difference in predicted maximum bench press between Model M and Model E does not exceed 30 pounds. For how many weeks should Mr. Passwater use Model M? Give a reason for your answer. So the difference between Model E and Model M. So difference signals subtraction. So E of T minus M of T, the difference between them should not exceed 30 pounds. Should not exceed, meaning less than. So my difference, my subtraction, needs to be less than 30. So I already have in Y1 M of T because that is my regression. In Y2, I want to put in E of T, which is my secant line. The problem is right now I don't know my secant line. So I want to write my secant line equation first. So E of T is going to be equal to an initial value, but it doesn't have to be an initial value. It's one of my starting points. Remembering that my starting point on my graph, I'm going to use 9, 270. So 270 plus my average rate of change times that value subtracted from T. Okay, but my average rate of change I'm going to put in as 40/7. I want it to be exact. I don't want to use that decimal that I rounded in B1. So let's go here. Into Y2, I am going to put 270 plus 40/7 times x minus 9. If you want, you can graph it, and now you see that secant line. It's kind of what we talked about in the previous question, where my secant line goes above it. You can actually zoom out if you wanted to, or change your window and see that interval over there for greater than 12 like we just talked about. But I need to go back to the question because now I have my secant line, but remember, that's not what I'm actually looking for. I need to compare this part. I'm going to leave these two in Y1 and Y2, but I'm going to deselect them, and I'll show you how to do that in a minute. In Y3, I'm going to put in E of T minus M of T, but I'm actually going to put in Y2 minus Y1 to make it a little bit easier for myself. And then in Y4, I'm going to put in 30. And I'm going to do this side as Y3, this side as Y4. I'm going to go back to my calculator, go back to my Y equals. I'm going to deselect these. I'm going to go over to the equal sign and hit enter. And now it unhighlights the enter, which means that those two equations are still stored, but if I go to my graph, they're not being graphed right now. So back to my Y equals, they're deselected, that's great. I am going to do E of T, Y2, minus Y1. And I'm going to put in 30. And then I'm going to zoom 6 this just to get back to the original window. You can now see the black is my subtraction, but remember I'm putting in Y of 30, so I'm not going to see anything right now. So I'm going to adjust my window. I'm going to make my Y max 50. And I now see it. Here is 1 point over here. I'm going to go and extend this a little bit as well. So I'm going to go back to my window and extend my X max maybe to 50 as well, just to be safe. And here we go. So I need to find this point of intersection because I want this part. Remember the question said, for how many weeks should Mr. Passwater use Model M? So this is going to be where this exceeds, where it now exceeds, goes over 30 because the pink line is 30. So I want to stop it right here. So I'm going to find my point of intersection. second trace 5. Enter 3 times. Here is my point of intersection. So at 17 weeks, Mr. Passwater should no longer use model M, because after that, the difference will exceed 30 pounds. And if you want, you can even graph it and show like your picture. And all of this scrap work that I have over here is showing your grader that you are doing this mathematically. You're using your tool of your calculator, but you're doing this mathematically. So hopefully this explains how to do it. Like I said, in my opinion, these are, in general, very challenging questions. I think that FRQ2 is very difficult with these analysis questions, but of all the analysis questions, this FRQ is the most challenging that I have seen so far. So hopefully you got something out of this. I reviewed some calculator steps with you, some manipulation of the calculator with you. If you don't understand this question, please do not panic. It is not the end of the world. This is on the more difficult side.